All right, so this is just a brief introduction to the carbon cycle activity that we're going to do today. You should have your notes for the carbon cycle. You should have, I think, 6 different processes in the carbon cycle, and let's talk about what we're going to do with those. So first of all, just to recall and recap what we already know about carbon. If we think back to the macromolecules, we could remember that carbon as an element serves as a backbone for a lot of different compounds. Okay, if we think about carbohydrates, a macromolecule, this carbohydrates are made out of C's and H's and O's. The C is the carbon. Pretty much all of the macromolecules have carbon in them. Okay, they're very connected. They're kind of the extroverts of the element system. I don't know if that's okay to say, but so they're in everything. They're all over the place. Very important element in macromolecules. Where do we find carbon in nature? Well, in the hydrosphere, right? In the water, the lakes and the oceans and the rivers. We'll find this dissolved as carbon dioxide. We might find it as carbonic acid. Okay, this is kind of, it gives ocean a little bit of acidity, a little bit of a, an acid pH. We'll learn about that in a little bit. But yeah, it's dissolved in the hydrosphere. In the biosphere, it is in all sorts of macromolecules. We could not be alive without carbon. So it's in all living organisms. And a lot of things that have died, but maybe once were living organisms. If this tree here falls in the forest and dies, well, that carbon in there that was in the carbohydrates and the cellulose and the proteins is going to stay in there until it becomes a fossil fuel in the ground. Okay, so big item in the biosphere. The geosphere, same idea here. The carbon is going to be deposited into the soils as fossil fuels, and in the atmosphere it exists as a CO2, carbon dioxide. This becomes one of our greenhouse gases, as we'll learn later, but carbon is all over the place, and the cycling of that carbon is just as important as the cycling of water. Okay, when the water cycle is out of balance and we have too much water as liquid on the earth, we might get flooding, or not enough water ends up with a drought. Okay, same idea with the carbon. If we have too much carbon dioxide in the atmosphere versus down here in the soil, then things can start to get a little wonky in the world. So we're going to learn about that. So how does carbon move through the carbon cycle? Well, the processes that it utilizes are the ones left in your notes. So I want you to look through those and read the descriptions, okay, as we did with the water cycle notes. And I want you to note why photosynthesis and cellular respiration are included again. Okay, why do you think that is? They were part of the water cycle. Photosynthesis and cellular respiration cannot occur without water. They also can't occur without carbon. Okay, so that's kind of where the water cycle and the carbon cycle intersect. So those are two very important processes. That's why they're included twice. So here's what we're going to do with this today. We're going to do Pictionary again. Okay, I think this will get your brain thinking about what in the world is going on with this carbon. What form is it starting off as? What form is it ending up as? So you're going to draw similar Pictionary diagrams of the carbon cycle processes. Okay, add photosynthesis and cellular respiration in, but this time you're going to focus on carbon and not water. Okay, find another partner in the class that's done with theirs and see if you guys can guess each other's processes. Okay, and then once you've done that and given each other valuable feedback, I want you to take a large piece of paper and map out a landscape. Okay, put in a hydrosphere, a biosphere, a geosphere, and an atmosphere, right? Give us some water, some living things, grass, plants, a lot of fungi if you want to make me really happy, some soil, and the atmosphere. And then use some arrows and put in some labels to show the movement of water and carbon. Make sure you work in all of those processes and draw a model of the water and carbon cycles. Okay, where do they intersect? Where are they separate? And add extra detail as you see fit. Okay, get real creative and have some fun with this.